We have the formula in the table below to find the antiderivative of a function. If you have a function with the c times f of x, then what all you need to do is just keep the c and find the antiderivative of f of x is the big F of x. The plus is still the plus. For the x to the n, the antiderivative, what do? Is we will increase the exponent one step and then divide it by the exponent n plus 1. The antiderivative of the cosine function will be the sine function. The antiderivative of the sine will be negative cosine, and similar for tangent square, the secant square, the tangent, the secant tangent is the antiderivative will be the secant. So you can look at the derivative formula and you can check that if you take the derivative of all of this, you will get the answer is this. So we will just use the table and apply for example number 2 and number 3 below, and more problems that we have to find the antiderivative. So if the derivative function g of x is 4 sine of x plus 2 x to the 5th minus square root of x divided by x, our job is to find the function g. So this kind of problem is just like we go in opposite as what we learned before, right? Okay, so before that, I will rewrite the function g prime of x. So I will get 2x to the 5th divided by x and square root of x divided by x. Then it's equal 4 sine of x plus 2 x to the 4 minus on the top you have this is x 1/2 and you divide, so you use quotient rule, so you will minus, so 1/2 minus 1 is x to the negative 1/2. So the function g of x, which is antiderivative of the function g prime of x, will be, we're gonna keep the constant 4 is just the first one, it says so, keep the constant, and then we will apply with a function psi, the antiderivative will be the negative cosine. Okay, so negative cosine of x plus, we're gonna keep the constant 2, and then x to the 4, we will apply this formula. So we will get x, 4 plus 1 is 5 and divided by 5. Minus, doing the same thing, apply the same thing, minus negative 1/2 plus 1 will give us 1/2. And then we divide it by 1/2. Now let's simplify this a little bit. And also we remember to add in the seed, okay, for the most general antiderivative function. So we have 2 over 5 x to the 5th minus, so divide by 1/2 is same thing as multiply by 2, and then this is square root of x plus c. In example number 3, similarly, we want to find the function f. Let's rewrite the f prime of x as x times x 1/2, and we got 3 over 2. Then we will use the formula is if we have x to the n is the derivative, so the antiderivative will be n x to the n plus 1 divided by n plus 1. So the function f of x will be x 3 over 2 plus 1 divided by 3 over 2 plus 1. 3 over 2 plus 1 will be 5 over 2. And we remember to add the c so that we can find the most general formula for the antiderivative function. Then we simplify this. So we get 2 over 5 x over 5 over 2, x to the exponent 5 over 2 plus c. Another to find c, we will use the second information, which is this one. So that means if we plug in x equal to 1, then we have 2 over 5, 1 to the 5 over 2 plus c, and this equal to 2. So it's going to be 2 over 5 plus c equal to 2. We solve for c. Then we will get 10 minus 2, which is 8 over 5. Now the specific antiderivative function will be 2 over 5x. I'm looking from here, okay? So 2 over 5x, 5 over 2, plug in the c is 8 over 5.